Hey there. Have you ever just looked up at a massive flock of birds, all turning at the exact same second, and wondered, how on earth are they doing that? Or, how does a silly meme just explode overnight? It looks like total chaos, right? But underneath it all, there's actually a hidden order. And today, we're going to dive into a really cool mathematical idea that explains exactly that.
And that brings us to the big question, the central puzzle for today. How do networks, and I'm talking about everything from people to computers, even to our own cells, how do they come to an agreement when there's no one in charge? How does a consensus just bubble up from the bottom?
So first up, let's talk about this incredible phenomenon, finding order in what looks like pure chaos.
Just think about it for a second. We see it everywhere. Birds flocking, ideas going viral, all these amazing, complex patterns just emerge. And here's the kicker. There's no central planner, no director telling everyone what to do. It all happens because of really, really simple interactions between individuals, just on a local level. Okay, so how does this actually work? Well, it all boils down to a set of rules that are almost laughably simple. Let's call it the simple whisper rule.
What's so wild about this is just how basic the process is. It's an algorithm you can boil down to 5 steps. 1, you start with a totally random network, a total mess. 2, you just pick any point in that network, what we call a node. 3, you look only at its immediate direct neighbors. 4, you see what color or label or opinion is the most popular in that little group, and you adopt it. And 5, you just do it again and again. That's the whole game.
So this super simple process actually has a name, the Chinese Whisper algorithm. Yeah, it gets its name from that old kids game you might know as telephone, where a message gets passed down a line. But here's the amazing twist. In the game, the message gets all messed up. In this algorithm, the network actually uses this process to find agreement. It's the total opposite.
Now, I know what you might be thinking. Okay, but couldn't this just go on forever, with all the points just flipping back and forth and never settling down? Well, this is where it gets really mind-blowing. This simple little rule comes with a rock-solid mathematical guarantee.
And here it is. This is the big reveal. This process is absolutely 100% guaranteed to stop. It's a mathematical certainty. It is impossible for it to get stuck in some infinite loop of changing its mind.
So it stops. What does it actually look like? Well, it always settles into a stable state. And what that means is that communities have formed. The initial chaos, that random mess we started with, has actually organized itself into these stable, agreed-upon groups, all from that one simple rule of copying your neighbors. Okay, so this is all really fascinating in theory, but where does it actually show up? I mean, what good is it in the real world? Let's take a look.
Oh yeah, the applications are staggering. I mean, social media platforms, they use versions of this to find communities of people with similar interests. Biologists use it to figure out how our cells coordinate without a brain. It helps massive, decentralized computer systems all get on the same page. It's even used to sniff out fake news networks by finding clusters of accounts that are all acting a little too much alike. And the list goes on, modeling opinion spreads, organizing huge amounts of genetic data, even making city traffic flow smoother. It's everywhere.
You see the common thread here, right? All of these amazing applications point to one deep, fundamental truth about our world. Simple, tiny, local interactions are what create these huge, complex, global patterns. You just don't need a boss to create order.
And this idea, it has implications that go way beyond just tech or science. It really forces us to zoom out and look at the bigger picture.
So let's just step back and ask, why does this really matter? Well, first, it's proof that you can get mind-bogglingly complex order from dead simple local rules. Second, it shows that consensus, that feeling of agreement, can just emerge organically, no central control needed. And maybe most powerfully, it gives us a mathematical blueprint showing that stability isn't just a hopeful wish in decentralized systems, it's actually achievable.
You know, one of our sources just put it perfectly. This isn't just about graphs and computer code, it's about finding stability in chaos, structure in randomness, and unity through diversity. It's a profoundly human idea, just discovered through the language of math.
Okay, look. The best way to really wrap your head around an idea like this isn't to just listen to me talk about it. You gotta play with it. So now it's your turn to explore. So let's get curious. What do you think would happen if you tweaked the rule just a little bit? Like, what if instead of just needing a simple majority, a point needed a 2/3 majority of its neighbors before it would switch? How do you think that would change the final picture? Would communities form faster, slower, or not at all?
Or how about this one? If you look at a starting network, can you spot the influencers? Can you predict which points, just by their position, are going to have the most sway in deciding the final color of their entire community?
And that right there, that's the whole point. Math isn't just some dusty subject about solving for x. It's a powerful lens, a tool for discovering the invisible rules and hidden patterns that shape everything in our world, from our friendships to our very biology.
I want to leave you with one last thought, and it's a big one. In mathematics, as in life, local actions create global consequences. The beauty is in understanding which actions lead to which consequences.
So, look around. These patterns are literally everywhere, all the time, just waiting for us to notice them. Which brings me to my final question for you. What patterns will you discover?